Hey guys, so we're going to talk about solving quadratic equations by the greatest common factor, alright? So first, let's briefly cover what is greatest common factor, okay? Greatest common factor is it's just things that all the terms share. So for example, let's look here. We have 9x plus 6, okay? Well, 9 and 6 both have a number in common, right? What number do both 9 and 6 have in common? A 3. So we can say 3, open up parentheses. Okay, now this is like division, okay? It's kind of like I'm dividing both of these by 3 because I'm factoring out a number, okay? When you factor out something, it's like division. So 9 divided by 3 is 3. So 9x, when I pull out this 3, becomes 3x. Plus 6, I pulled out a 3, so it's like division, so that becomes 2. So I just factored 9x plus 6 down to being 3 times 3x plus 2. So this right here, what we just did, is called factoring based on the GCF, the greatest common factor. Okay? So now, let's discuss how would I use this idea to actually solve if I had, how do I make this eraser bigger? Size. Okay, that didn't work. That's going to change the size of my pen. There's got to be a way to do this. Let's see here. Okay, so let's consider, I don't know how to erase that, so we're just going to ignore it for a second. Okay, let's consider instead that we have a different idea. Let's say, in this case, we have something that looks more like this. Let's say we have something that looks like 3x squared plus 12x. Okay, so first we notice that both 3 and 12 both have a number in common. What number do both 3 and 12 have in common? They both share a 3. Okay, now you might be tempted to say, okay, great, and move on and throw open a parentheses, but we're not there yet. X squared and x both have a number in common. Well, they both have something in common. They both have an x. So we have 3x and we open up parentheses, all right, because now we've pulled out of both numbers and variables. And now think division. 3 divided by 3 would be 1. X squared divided by x would just be x. Plus 12 divided by 3 is 4. X divided by x, they're both gone. So now I have two new terms. I have 3x and I have x plus 4. Technically the word term isn't appropriate, but I'll use it a lot. Okay? So let's say I actually wanted to solve this. Let's say it was equal to 0. Okay? Well then once I'm here, I could set both of these pieces equal to 0. Okay? And then I could just simply finish solving for x. So x would equal 0 and x would equal negative 4. All right, let's look at another problem. Okay? All right. Let's say we have something like 9x squared plus 21x. And we say that's equaling to 0. All right? The way I would solve this is by factoring out a 3, because 9 and 21 both have a 3 in common. It's not always 3, guys. I just noticed a lot of my problems are always pulling out a 3. That's just a number I'm coming up with. All right? X squared and x both have an x in common. So I pull an x out of both of them since they both have an x, all right? Now let me show you why this is possible, okay? So we pull out this and we say this becomes 3x plus 7. It is important in math that we never make an untrue statement. In other words, we're never like making something become what it wasn't. It's kind of like, you know how you could have a dollar bill and you could have 4 quarters. They both represent the same number. They both represent the same amount of wealth. They both have the same purchasing power of $1, okay? Both of these steps are the same thing, just different ways of writing it, okay? Because look, if you were to multiply the 3x back in, which we're not going to do, but if you were going to, 3 times 3 would give you the 9, x times x would give you the x squared. 3x times 7 would give you the 21x, and the plus sign would stay right there, okay? So then why do we do this? Why am I caring about this ability I have? Okay, well let me show you why. Now that we're here, it's just like we did on that last problem. I can set each piece equal to 0. So then I can say 3x plus 7 is equal to 0. Divide by 3, divide by 3. I get x equals 0. Subtract 7. So you get 3x is equal to negative 7. Divide by 3, and you get x is equal to negative 7/3. And if you were to take these answers and plug them back into the equation, you would see that they both work. In other words, when you plug a 0 in for here and here, this whole left side is going to become 0, making 0 equal 0, which is what I want. And if you were to plug in negative 7/3 into here and here, you would get 0 equals 0, which is, again, what I want. Okay? So that's the idea of how you solve by greatest common factor. Let's do one more just for good effort. All right? Let's say we have something like, let's say 7x cubed plus 49x squared is equal to 0. Okay? Well, you'll notice that we have two terms, and they both have a 7, and they both have an x squared in common. So if I take out 7x squared out of both of them, that'll give me with x plus 7. The reason that is, let's back up just a second to make sure we understand what just happened. 7x cubed, 49x squared. 7 and 49 both share the number 7. X cubed is 3x's multiplying by each other. X squared is 2x's multiplying by each other. So they both share 2x's. Whoops, I just resized stuff. That was weird. They both share 2x's. That's why I pull an x squared out of both of them. But on the x cubed, it still has an x maintaining. On the x squared, it's completely now outside. So you should always pause for a second and ask yourself, okay, if I was to multiply this back in, would I get what I want? Would it go back to this original statement? Well, 7x squared times x. Well, 7 times 1, the understood 1 right here would give me 7. X squared times x would give me the x cubed. 7x squared times 7. 7 times 7 is 49. X squared times, there is no other x here, so it just attaches along. So it'd give me back here. So this statement equals this statement. So that's good. And now I can set each piece of this equal to 0. Now why can I do that, just out of curiosity? Well, I know that I can set each piece equal to 0 because what's going on between the 7x squared right here, what's going on between the 7x squared and the x plus 7? They're multiplying. And we know that if I was to find a way to plug in a value for x right here that made the 7x squared part become 0, we would get 0 times, and then whatever number I plugged in here for x doesn't really matter because what's going to happen? Well, I'm going to add that number 7, but the 0 is going to multiply by that number, thus canceling out the entire thing to making it 0. And the same idea right here with the x plus 7. If I was to find, well, let's solve for that real fast. X equals negative 7. If you were to plug in negative 7 right here, you get negative 7 plus 7, which is 0. So now we have 0 in the parentheses, and we'd have 7 times negative 7 squared on the outside. But does that actually matter? Because 0 times anything is still 0. So let's finish solving for x over here. So we divide by 7, divide by 7. So x squared is equal to 0, square root both sides, and we get x is equal to 0. So therefore, my solution set is 0, negative 7. Both of these values, if you were to plug them in one at a time for x, so 0 here, 0 there, it'd give you 0 on this side. Negative 7, if you plug in here and here, it'll give you 0 on this side. Alright guys, I hope this video was helpful. Let me know if you have any questions. Thanks.